Alright, so we're going to start notes for the atomic structure. This will be our first notes for the new unit. Atomic structure has to do with the parts of the atom. So we have three main particles. The first one is the one with the plus sign. That'll be our protons. The other particle in the center is our neutrons. And the center part that holds the protons and the neutrons is called our nucleus. The third particle that we have is an electron. That's the one that's up top. And our electrons are going to be on those lines that go outside of the nucleus, and I have them labeled here as electron cloud. So most of this table should be review, going over each of the particles. Our first particle is a proton. Protons have a positive charge, and protons are located in the nucleus of the atom. Next, we have our neutrons. Our neutrons have a neutral charge or zero charge. And neutrons are also located in the nucleus of the atom. Lastly, we have electrons. They're going to be our negatively charged particle of the atom. And as we talk more about the atom, we'll learn more about what goes on outside of the nucleus. But electrons are located outside of the nucleus, and we usually call that an electron cloud, or we sometimes call those orbitals. So now the last column is probably not review, but how we would determine protons, neutrons, or electrons in an atom. For our protons are going to be our atomic number, and we'll talk about that more a little bit further down this page. Our electrons, we'll skip to the bottom, they're equal to our number of protons whenever we're talking about a neutral atom. And this year in 8th grade, we're almost always talking about a neutral atom. So you can just remember that protons equal electrons in a neutral atom. And then I saved neutrons for last because they're the most complicated of the three. Neutrons are going to be the mass number of an atom subtracting the number of protons. So we'll use our mass number and then subtract the number of protons to find our number of neutrons. Alright, so for the bottom half of this sheet, we're going to go through how we would actually solve and find those three particles above. We'll talk about how we use our periodic table squares. So we're going to be using our periodic tables for this entire unit. Make sure you know where yours is in your agenda. You also glued one in just for yourself for the unit, so you should be able to use your periodic table. So the first thing that you'll notice on the periodic table is the number for every single element, and that number is what we call our atomic number. Our atomic number is different for every single element. Every element has their own unique atomic number, and the periodic table is organized by atomic number. So if you look, at the very top left is number 1, hydrogen, and it goes all the way down to the bottom right, up to 118. Every periodic table square also has an element symbol or an atomic symbol. This is going to be that one capital letter or one capital and one lowercase letter that signifies what element we're talking about. Each periodic table square will also have the element name. In this example, it's oxygen. And then the periodic table also has an atomic mass, and this will be the mass of an atom. And usually when we talk about atomic mass, we're going to round to the nearest whole number. And like it says above, we can use the information on our periodic table to determine our protons, neutrons, and electrons. So atomic number represents the number of protons, which is equal to the number of electrons in a neutral atom. So our atomic number is our protons and electrons. And then to find our neutrons, we're going to take our atomic mass, round it to the nearest whole number, and subtract the atomic number or the number of protons from that. Now to work through a few examples. So our first example is carbon. You can see our periodic table square here. At the top you can see that our atomic number is 6, and that is what tells us our protons and our electrons. So since we know our atomic number was 6, we can fill in our number of P and number of E up on the line is 6. Next, we can look at our square and see that our atomic mass is 12.011. So rounded to the nearest whole number, that's 12. Now to find number of neutrons, we take our atomic mass once it's rounded, which is 12, and we subtract our number of protons, which is 6, which gives us 6 neutrons. And we can write our 6 up on the number of n line because we have 6 neutrons, because 12 minus 6 gives us 6. Let's do another example with neon. Here's our periodic table square. And you can see our atomic number for neon is 10, which means that's how many protons and electrons we have. So for our number of P and number of E, we can fill in the atomic number of 10. We can look at the atomic mass on the periodic table square is 20.179, and that's going to round to the nearest whole number of 20. So to find the number of neutrons, we're going to take our atomic mass rounded, 20, and subtract our atomic number, 10, to give us 10 neutrons. And we can write our number 10 in the number n line up above. And one more example, we'll do potassium. Here's our periodic table square. You can see the atomic number is 19. That's our number of protons and electrons. So on the number P and number E lines, we're going to fill in the atomic number, 19. The atomic mass from the periodic table is 39.098, so rounded to the nearest whole number is 39. And to find our number of neutrons, we take our atomic mass rounded, 39, and subtract that atomic number, 19, to give us 20 neutrons. And so we'll take our 20 neutrons that we found below and fill it in on that number n line up above.